AB Calculus 3.9, day number 2, derivatives of exponential and logarithmic functions. Okay, example number 1. Let's zoom in here a little bit. Not make it too crooked. There we go. That's pretty good. Example number 1 says find the derivative of y equals e to the x using the definition of the derivative. We would like to find the derivative of e to the x using the definition. Sketch the graph of e to the x, and then, using the definition, find the derivative of the function at some arbitrary x and x plus h. Okay, so y equals e to the x. Let's sketch that. We went through a little bit of this in the last lesson. Here's the point 0, 1, and horizontal asymptote, y equals 0. All right, we want to find the derivative of that. So the derivative, if f of x equals e to the x, will equal the limit, as h goes to 0, of f of x plus h minus f of x all over h. Okay, so the way we would want to go about this is to take the limit as h approaches 0, and I'm going to rewrite e to the x plus h as e to the x times e to the h. What that allows me to do is to factor out an e to the x in the numerator, which leaves me with e to the h minus 1 over h. Okay, so what we end up getting here is that f prime of x is equal to the limit as h goes to 0 of e to the x times the limit as h goes to 0 of e to the h minus 1 over h. Yeah. So now, what is the limit here as e to the h minus 1 over h as h goes to 0? Well, if we use our graphing calculator, which I'm not going to be able to visually help you with, but this limit actually ends up just going to 1. So f prime of x is going to equal 1 times the limit of e to the x as h goes to 0. Well, h is not part of this function, therefore whatever h is going to is irrelevant. So we get e to the x times 1. So this is the only function whose derivative is itself. It's really quite awesome. So what that means, though, you guys, is that say at this point, right? Let's take 0, 1. At 0, 1, the slope of the tangent line to the function right there, the slope of that tangent line is 1. At 1e, let's go here to 1e. That's the point 1 comma e. The slope of the tangent line there is e. So the slope at any point on the function is the same as the output on the function. It's just unreal. Okay, we're going to find the derivative now of a to the x. Let's suppose that a is not e. Okay, an example of a to the x might be 3 to the x. This is an exponential function, y equals x cubed, not the same. That's called a power function. Okay, their derivatives are absolutely very different. There are two ways to find this derivative, so let's talk through a little bit of it first. Remember, e to the ln of x is equal to x, so you could rewrite y equals a to the x as y equals e to the ln of a to the x. I know that seems kind of weird, but the e and the ln reduce, which really is just saying then that y equals a to the x. Now we can use the exponent rule, bring that x down in front, to make y equals a to the x equal to e to the x ln of a. All right, so let's write that out. Y equals e to the x times ln of a. All right, now let's keep in mind that originally we're starting with y equals a to the x. And I want to know what y prime is equal to. All right, so I'm going to take the derivative of this thing. So y prime will be this thing, right? E to anything, its derivative will be that same thing times the derivative of the exponent. The derivative of ln of a times x is just ln of a. So y prime is equal to ln of a times e to the x times the ln of a. And we said originally that e to the x ln of a is equal to a to the x. Therefore, y prime is equal to ln of a times a to the x. So how come if y equals e to the x, then y prime is still equal to e to the x? Well, technically speaking, ln of e is just 1, so it's hidden. All right, so if y equals a to the x, then y prime equals ln of a times a to the x. All right, another way to get to the same result is to look at method 2 for finding this. We're going to do this implicitly. Therefore, if y equals a to the x, then we could rewrite as a log base a of y is equal to x. All right, now I'm going to use the change of base formula and write this as ln of y over ln of a is equal to x. All right, this expression right here is equivalent to that using the change of base formula. Okay, so then what that tells me is that x is equal to 1 over ln of a, which is just a constant, times ln of y. Now I'm going to take the derivative of both sides with respect to x. Okay, and derivative with respect to x at the right side, 1 over ln of a, remember just a constant, ln of y. I'm going to have to use some implicit differentiation here. Well, the derivative of the left side is 1. The derivative of the right side is going to be 1 over ln of a times the derivative of ln of y, which is 1 over y times dy dx, or y prime. Okay, now I need to solve for y prime. So I'm going to multiply both sides by ln of a and y. So y prime is equal to ln of a times y. And what was y equal to? Well, it was equal to a to the x. So y prime is equal to ln of a times a to the x. I get the exact same answer using an implicit method. Okay, let's continue with some more examples. So let's go. Okay, so we already know the derivative of ln of x is 1 over x. However, we're going to derive it implicitly. So if y equals ln of x, then e to the y equals x. All right, and now I'm going to differentiate implicitly because I know the derivative of e to the something, right? That's going to be the same thing times the derivative of the inner function. So the derivative of e to the y will be e to the y times y prime. The derivative of x is 1. Therefore, y prime is equal to 1 over e to the y. And I know e to the y, that's equal to x. So y prime is equal to 1 over x. All right, how about y equals log base a of x? No longer natural log. Now it's log base a of x. Okay, so I'm going to write that implicitly. Writing this as a to the y equals x. Okay, now I'm going to take the derivative of both sides. Okay, and using what I know from before, the derivative with respect to x of a to the x is ln of a times a to the x times the derivative of x, which is 1. The y is going to play a slightly different role. This will be ln of a times a to the y times y prime. Derivative of x is, of course, 1. So y prime will equal 1 over ln of a times a to the y, times a to the y. I know what a to the y is. It's x. All right, I see that from where I started at the beginning. So this will be 1 over ln of a times x. All right. So if y equals log base a of x, then y prime is equal to 1 over ln of a times x. Okay, let's look at an example involving that. Okay, so again, if y equals log base a of x, then y prime is equal to 1 over, I'm going to write it as x ln of a. Okay, let's look at that and how that applies to this situation. So we got base a, that's cool. We got a to the x, a to the sine x, which is kind of like playing the same role as x here. Okay, so I can take y equals log base a of a to the sine x, and initially just take this format over here and plug in what I know. Okay, so I'd have 1 over, in this case, x will be a to the sine x times the ln of a. Now the one thing I'm missing here is that the derivative of x ended up being 1. So it didn't really show up like it has in the past. You know, with e to the x, we said, well, what's the ln of e? It's 1. That's why, you know, we get 1 over x for the derivative of ln of x. Unlike this, which is 1 over x ln of a. So what should we do here? We also need to multiply by the derivative of a to the sine x. So if y equals a to the x, then y prime is equal to a to the x times ln of a. All right, so what would be the derivative of a to the sine x? Well, that would be a to the sine x ln of a times the derivative of sine x, which is cosine x. All right, so then what we would get here is the derivative of a to the sine x would be a to the sine x ln of a times cosine of x. And you're going to see something very crazy actually take place here. The a to the sine x reduce, the ln of a reduce, and we get cosine. Now, there's got to be an easier way to come up with that. Well, if you look back at the original problem, log base a of a to the sine x. What have we said in the past if we have y equals ln of e to the x? What was ln of e to the x equal to? Well, it was equal to x. Therefore, this is technically equal to sine x. And what's the derivative of sine x? It's cosine x. Quite the runaround. Okay, let's continue on the next slide. All right, here we go. We got y equals e to the x. Its derivative is e to the x. A little bit of review. A to the x is a to the x ln of a. ln of x, 1 over x. Log base a of x is 1 over x ln of a, and absolute value of x is x over absolute value of x. Okay, so let's continue with some logarithmic differentiation. Sometimes it's easier to find the derivative if we could somehow simplify the function first. We can sometimes do that by taking the log of both sides and then finding the derivative. So take the natural log, simplify both sides. Once you have the right-hand side simplified, then take the derivative of both sides. So then solve for dy dx. You have your answer in terms of y. Substitute y back in. You got your derivative. So that's a lot of words for, let's just figure this out as we go. Okay, so if y equals x to the x power, then I'm going to take the derivative, or excuse me, I'm going to take the natural log of both sides. What that allows me to do is get this upper exponent down in front. So the natural log of x to the x allows me then to rewrite it in this form. Bring that x down in front, And now I can use implicit differentiation. So I'm going to take the derivative of both sides with respect to x, and the derivative of the right side with respect to x. And we're going to do a little operation with that. So this will be 1 over y times y prime. This will be product rule, which will be 1 times ln of x plus x times the derivative of ln of x, which is 1 over x. So let's work our way back up here. This is y prime over y is equal to ln of x plus 1, right? X times 1 over x is 1. All right, so y prime will be equal to ln of x plus 1 times y. Well, what was y? It was x to the x. So y prime ends up being x to the x power times ln of x plus 1. You could write that expanded as well. That would be x to the x ln of x plus x to the x. It's pretty nasty. All right, let's look at the last example for this video. Y equals x to the sine x. So again, natural log of both sides. Natural log of both sides. X to the sine x. That allows me to bring the sine x down in front. Multiplied by ln of x. Take the derivative of both sides. I'm not getting lazy here with notation. You should not either. Take the derivative of the right side as well. We're going to use product rule, some chain rule, implicit differentiation. It's starting to get kind of heavy. This will be 1 over y times y prime. The right side will be cosine x times ln of x left alone plus sine x times 1 over x. That's the derivative of ln. So y prime over y will equal cosine x ln of x plus sine of x over x. And of course then we solve by multiplying the expression cosine of x ln of x plus sine of x over x times y. And y is x to the sine x. All right, again, I could, if I wanted to, distribute. That would be x to the sine x times cosine x times ln of x plus x to the sine x times sine x over x. Whew, that's a lot of work, but there you go. Either of those forms is just fine. Guys, we'll see you in the next video. Have a great day.